next we're going to talk a little bit about something called unit vectors. And a unit vector is a vector of magnitude 1, which makes sense, just like the unit circle was a circle with a radius of 1. The standard unit vectors are called I and j, I being a vector of unit 1 pointing directly in the horizontal position, j being a vector of unit 1 pointing directly in the vertical direction. And each vector can be represented by the sum of standard unit vectors. So if I want to name the vector 7, 6 by using standard unit vectors, these being my standard unit vectors here, I could say, well, if I take 7 and multiply it by the vector 1, 0, because that's my x component, and 6, and multiply that by the vector 0, 1, or the y component, this is the same as saying 7i plus 6j. And typically I and j will have these vector signs over them. In our book, they'll notate these standard unit vectors with boldface i's and j's and not use the little arrow. Other books will use the arrow for I and j. But 7i plus 6j says the same thing as 7, 6. It's just saying that I and j are these unit vectors. If we want to write AB as a sum of unit vectors, first of all, what I need to do is notice that A and B represent 2 points. So this is a vector out in space. I'll just do a random drawing. Here's vector A, B, like so. And this vector is made up of a initial point of 2, 3 and a terminal point of 7, 20. In other words, we have the coordinates of the tip minus tail, but we haven't named the vector. Let's name the vector first by going tip minus tail. So I have 7 minus 2 and 20 minus 3, and that's going to be my vector AB. This gives me 5 and 17 for that vector AB. And if I want to represent that in terms of unit vectors, I can say that's 5i plus 17j. And that's equal to my vector AB. If I want to find the magnitude of AB, keep in mind magnitude just describes how long it is relative to its distance from the origin in standard position. And if I know it has a horizontal length of 5 and a vertical length of 17, I can find its magnitude. Notice magnitude is given by these double sets of what look like absolute value signs. I can just do a Pythagorean calculation to find out this guy's length. So what I have is 17 squared plus 5 squared, square root that, and that'll give me the magnitude. And that's equivalent to square root of 314. We could simplify that. We could also give it as just square root approximation. And that's going to be 17.7. Now if I want to calculate a unit vector, notice this doesn't say standard unit vector. This is a unit vector. For any regular vector, there is a calculation that I use of the vector itself divided by the magnitude will give me the unit vector. So here's the vector negative 2i 4j. So that's roughly this vector right here. And if I want to name a vector that has a length of 1 or a magnitude of 1 pointing in the same direction, I take the vector's coordinates and divide that by the magnitude of the vector itself. So I know that I have a length of 2 on the horizontal, a length of 4 on the vertical. So the magnitude of this vector is given by 2 squared plus 4 squared square rooted, or in this case 2 root 5. And if I want to find the unit vector of this same vector, I take the negative 2, divide that by the magnitude of 2 root 5, and that's its I component, or its horizontal component. And then the vertical component will be given by 4 divided by 2 root 5. And that's the j. This gives me negative 1 over root 5I plus 2 over root 5j. Some books will leave it like this, other books will rationalize, giving you root 5 over 5I and 2 root 5 over 5j. Lastly, we're going to write a vector in the form of AI and b times the unit vector j, given that it has a magnitude of 7 and the angle it makes with the positive x-axis is 97 degrees. Well, think about that. Here's my vector, if you will, that is given by a magnitude of 7 and 97 degrees. Well, if I want this in ij form, all I really need to do is find my x and y components. My x components are given by the radius value, or the magnitude in this case, the 7 times the cosine of 97, and my y is given by the magnitude, 7, times the y component of 97 degrees. 7 cosine 97 degrees is roughly 0.85 of the negative type, which makes sense since it's in the second quadrant. And 7 sine 97 is about 6.95. So if I convert those to unit vector form, I have negative 0.85 I plus 6.95 j.